All right, the video shut off while I was doing this problem. So we graph the functions, we find the region, it's going to rotate around the line y equals -2. Every vertical rectangle has the same top curve and bottom curve, so we can use vertical rectangles. That means we will use the differential of x. That means we need an x interval. If you don't see the x interval on the graph, then you can just set these equal to each other, and we get 0 and 1. So the intervals from 0 to 1. Let's find the radii. And when I was doing this, I made a mistake here. We have Vigar is from the axis to the furthest part of the region, and that's going to be top. The top of that line is the reflected parabola. My mistake was I made the bottom of the line, which it shouldn't be, the other function, but the bottom of the red line is -2. So we go top minus bottom, -2, and this small radius is from the axis to the closest part of the region, so that's going to be top. The top of the green line is the other parabola. The bottom of the green line is -2, top minus bottom. Then we need the area of a washer. So it's going to be the large circle, and then we'll subtract the small circle from it. Big R, we're copying that from here. Little r from there. The volume of a washer is just multiplying it by the differential of x, and then the integral is adding up an infinite number of those washers. All right, last example. Sine and cosine. So cosine will have a low point right there, a minimum. And we are going to have the region end at y equals 0. So I guess the region's ambiguous, but this is it. This is the one we're going to work on. So the bounded by sine, cosine, and the y-axis. It could have been down here too. It just didn't specify that. Let's work on this region. And can we use vertical rectangles? Well, if we had a rectangle here, we have sine and cosine as the top and bottom. If we have a rectangle here, then we have sine and y equals 0 as the top and bottom. So maybe we should use horizontal rectangles. But then if we use horizontal rectangles, we would have sine as right and left, and then we would have sine is the right, cosine is the left. So either way, we have two functions. The functions change as we move through the interval. So why don't we just still use vertical rectangles, and we'll make two integrals. So we'll have an integral that is for that region and another integral for that region, because the bottom part of the region changes. Let's go ahead and use do the integral in terms of x, and we need to find the intervals, x interval we need to find that intersection, and we need to find that point, and we know that point. Sine and cosine intersect at pi over 4. If you didn't know that, you could look at a graph or solve the equation sine equals cosine, and we know that cosine, if we looked at this, cosine ends at 2 pi, so that means this is pi and this is pi over 2. So we know cosine equals 0 at pi over 2, and then sine hits 0 at pi. So the intervals are from pi over 4 to pi over 2, and then from pi over 2 to pi. Alright, so now we have to have two different big R's and two different little r's. The region ends right here. The region is divided here at pi over 2. So we have to have big R 1 is going to be top, which is sine, minus -4. And so still in the first region, then we have to go axis to the closest part of the region. So axis to the closest part, and that's going to be top minus bottom, cosine minus -4. Let's go to the other region, and we go axis to the, that's a bad line. It needs to go up here because we're going to end right there. So here we have big R is top minus bottom, and the top is sine, and bottom is -4. And the region is at the x-axis, so we're going to go from the axis to from the axis of rotation to the x-axis. So that is little r, and that's top is 0 minus -4. Alright, and then let's just put all the steps together. We'll have two integrals. One goes from pi over 4 to pi over 2, and the other one is from pi over 2 to pi. We need to have pi big R 1 squared. We need to label these as R1, and this is R2, and that was R1 and R2 for the two regions. And here we have pi R2 squared minus pi little r2 squared. All right. pi. Big R1 was here. And so that's going to be sine plus 4. Sine x plus 4 squared. Little r was cosine x plus 4 squared. And here we have big R2, and that's sine x plus 4 pi sine x plus 4 squared. Little r2 is 4. And if we did all that on a calculator, hopefully we get that. Okay, we'll stop there.